Okay. Hello, everyone. My name is Scott Cruzard, University of South Florida. This is the quiz review for 1A. If you've been in for the last 15 minutes, you will have known that we were also on Blackboard Collaborate Ultra. If you want to ask questions, that's awesome. If you need to, though, you need to turn off one of your audios, or you're going to get both. So if you want to watch it on Twitch, or if you want to watch it here alone, you can watch it on Twitch, but you need to mute one of them, one of the web pages. So anyway, feel free to ask any questions that you have about the quiz. Someone's asking me how you can check into class. You've already done it because Blackboard Collaborate Ultra keeps track. Okay, so let's look at this lovely quiz here. Okay, well, the lovely quiz just decided to fail. Probably when the internet went down. Yep. Okay. Oops. We have a technical failure. When the internet went down, it killed the quiz. It was all set up. Now life is good again. Okay. So if we flip to the quiz, we want a shrubbery. Now, as you can see, it should say can be retaken. There will be a quiz retake on Canvas. Obviously, that's not set up yet. This office hours stuff is from when we were, in person. So last year, I didn't change the verbiage of the thing. Sorry. But yes, you can retake this quiz for half credit, for full credit. Most quizzes you could only take for half credit. For the first 2 weeks of Zen, we're going to have full credit retakes. Okay, then we'll go to half credit retakes. All right. So, what is your name? I'm Wiley Coyote. What is your quest? Beep beep. Have I taken calculus before? Yes. Acme Instant Calculus and Rocket Piloting course last year. All right. So, how do we feel about question 1 to 5? 1 to 5s, by the way, are in Blackboard Collaborate Ultra, where I am doing the polls again. Now I have to set up the poll again. Don't I? Crap. Polling. Stop. Question 1. 1 to 5. Yes, 5 is good. 1 is bad. How do we feel about question 1? There are people that don't feel good about question 1. Who are you people? Do you not know your name? Okay. Question 2. On the figure above, I want to create a function that satisfies these properties. Okay? So let's see. F of 0 equals 2. So what I'm going to do, this means that the point 0, 2 appears on the graph. X equals 0, y equals 2. So I'm going to put that there. F of negative 3 equals negative 4. X is negative 3, y is negative 4. All right, so how do we feel about those two conditions, 1 to 5? The fact that those are points. Stop, start. And you're free to, if you're watching on Twitch, you're free to ask me questions on Twitch as well. But just know that all questions that you ask on Twitch are public, whereas if you ask them here, they're restricted to people in the class. Okay. Now, let's hold off on this F is defined everywhere condition, and let's go ahead with this. For every x greater than 0, f of x equals negative 2. So that means that f of 1/2 equals negative 2. F of 1 equals negative 2. f of pi equals -2. No, the points are not all or nothing. There's partial credit on this. So everything starting from 0. So if I go to f of 0.5, it's -2. If I go to f of 1/4, it's -2. If I go to f of 0.0000001, it's -2. So I'm going to have an open circle here, and then everywhere else, I'm going to have -2. Okay? 1 to 5, how do we feel about that one? Now, let's deal with these next two conditions. I want it to be defined everywhere, and then I want it increasing from -6 to 0. So if x is greater than or equal to -6 and less than 0, f of x is increasing. That's what it means to be on an interval. Okay? So what I'm going to do is I'm going to make some notes. All right. Starting from -6 and going to 0, I want to be increasing. All right? Now, I want it defined everywhere. That means every x So what I'm going to do when I draw my graph, I'm going to do the following here. I'm going to do something. I've got a 2 here. I can make it increasing by just doing this. Something that looks like this. Okay? 1 to 5. How do we feel about that little maneuver? Now, do I need to connect them all? Well, no. No, you don't have to draw the arrows. As long as it's clear that you meant the whole thing, you don't need the arrows. Now, I don't have to. There's other valid ways to do this. For instance, I could have done this. This is a perfectly good function. I could have done that. I could have done this. That would be fair. I could have done something crazy, like this. It's my function. I get to play with it, as long as it meets the conditions. Let's go back to the canonical version here. Now, the other thing I need to check is my vertical line test. So did I pass my vertical line test? So I'm going to take my ruler here. Come here, ruler. And I'm just going to run it on the thing. Did I pass my vertical line test? Yes. You could do all sorts of things. You could make it half a parabola. You could do all sorts of fun things with it, as long as you meet your conditions. So check to make sure your conditions are met. So are my conditions met? Is f of 0 equal 2? Yes. Does f of negative 3 equal negative 4? Yes. Is f defined everywhere? Yes. For every x greater than 0, is f of x equal to negative 2? Yes. Is f of x increasing from negative 6 to 0? Yes. So there are 3 stages here, right? Step 1. Make notes. Step 2. Connect the dots or draw the graph. Oops, let's get rid of that ruler. Step 3. Check. All right, so how do we feel? The bracket is a hard endpoint. So negative 6 is included in this while 0 is not. Yes, exactly. Okay, so 1 to 5 on this graphing problem. Now, if you're having trouble with graphing problems, please come see me during office hours. I will be happy to help you. There's a question. Go ahead and ask your question. Be aware that the Twitch feed cannot hear your question, so I'll repeat it. Okay. You're not asking your question. Okay. Are there any other questions? Person did not ask the question. All right. Let's look at number 3. Here I've got a piecewise function. F be the function so that for every real number x, f of x equals these two things. What is f of negative 3? Well, I'm going to use this rule right here. So to do f of negative 3, I'm going to use this rule here. So I've got f of negative 3 equals 1 over negative 3 minus 2. Negative 3 minus 2 is negative 5, which equals negative 1 over 5. For f of 2, I'm going to go over the first rule here, and I'm going to wind up with 7. Okay? So 1 to 5, how do we feel about that? Question 3, A and B. That's reading a piecewise function is that skill. Okay. Oh, I'm sorry, A and C. You're right. Okay, B. The question is it okay if we just put 7, or do you prefer us to write it all out? Well, I'm a math guy. I prefer complete sentences, right? F of 2 equals 7 is a complete sentence. 7 is a noun or an adjective, right? But, there needs to be kind of a verb, a subject, a verb, a predicate. That's just me. I'll be okay with 7. It'll hurt my feelings. All right, f of negative 3. tenths. Well, I throw in 1 over negative 3 over 10 minus 2. I take a common denominator, and I wind up with negative 3 over 10 minus 20 over 10, which gives me, I did it right, right? 1 over negative 23 over 10, which equals negative 10 over 23. Because this right here, I just take the reciprocal. All right, so 1 to 5, how do we feel about B? All right. What is the domain here? Well, the domain, what would be the domain if I didn't have this first part or this bit? What would be the domain if just 1 over x minus 2? That would exclude 2, right? Because then I'd have 1 over 0. But notice here, it doesn't actually happen, right? I've got 7, right? That 0 point doesn't matter. Okay? So let's look at this function. If I look at this function here, let's give it a nice little thing. If I graph the function, I wind up with something that looks like this. But notice that it's actually defined for every real number. There's no point where, right, it goes off to negative infinity here. But, you know, if when I hit 2, when I plug in 2, I get 7. So it's actually defined everywhere. 1 to 5, how do we feel about this idea that this piecewise function defined everywhere? Parentheses. These are parentheses. I'm not including negative infinity or infinity. This is all real numbers or just negative infinity. You could also just write all real numbers. Yes, actually, there will be cases where we include the symbol for infinity. We'll get to that when we do 2 cops. But for the moment, we're not including infinity. Okay. Now, so as I said, you could have just written all real numbers. This next one is asking you to find the image. So what I wanted you to do, okay, what I wanted you to do was go over to Google and go image of a function. What the heck does Scott mean? And if you did that, you would have come up with something that looks like this. Image of a function. In mathematics, output, oh, you mean the range. But wait, you would have had this kind of picture here, where f is the domain, the codomain y, and sort like that. So that's kind of what I wanted you to do. You could have done that. You could have gone and found the videos, right? And what I wanted you to do was kind of, okay, once you figure out what it's asking for, right? I'm looking for the y values that I get when I plug in these x values. So 1 to 5, how do we feel about what it is I'm trying to find? Oh, D. I'm sorry, I didn't do D. I'll get to D. I'll come back to D in a moment. I didn't do D. We'll talk about F real fast. Okay? It's asking me to find the Y values. All right. So there are a couple ways to do this. All right. What I'm going to do is I'm going to say, okay, well, everything is less than 2, so I'm using this piece of it. Now, I'm going to draw my x space from 0 to 1. Now, if I'm at 0, I'm going to wind up here at -1/2. And if I'm at 1, I'm going to wind down here at -1. So it's going to flip. And this open here is going to be associated with an open here. And then everything in the middle is going to map to everything in the middle here. Now, the other thing I could have done is I could have gone over to, I could have graphed the thing. And I asked myself, okay, what happens when I'm between 0 and -1? So if you pull out 0 and -1, and you make a graph, this is the x values 0 to -1. And then I look at my y values. Well, my y values are from -0.5 down to -1. Of course, -1 is less than that. So I go from -1 to -0.5. And there is the piece of the function that I'm talking about. These are the x values. These are the y values. Okay? 1 to 5. How do we feel about that? Do, 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 do. Okay. So what's the big moral of the story? What's the point? Why am I torturing you like this? What's the point? This is the point. What we're interested in is mathematical reasoning. That's kind of the point to why you have to take this course before you do calculus. It's not just to learn calculus, but it's to learn how to figure out stuff. All right? When in doubt, in this course, draw a picture. If you don't understand what's going on, draw something. All right? And that's going to extend a lot. This idea of drawing pictures. Your brain remembers pictures much more easily. It can figure out things visually much more easily. And you need to do it on, you just need to draw a picture. Picture is good. Okay? So how do we feel 1 to 5 about this idea that when in doubt, I need to draw a picture? And I will do everything. I will be encouraging this idea of drawing pictures, okay? On tests, on quizzes, and stuff like that, you can't figure it out. You'll get partial credit for decent pictures, okay? So when you're not worried about it, draw a picture. You can't figure it out, draw a picture. It's much easier to reason in pictures. All right, this last one. What do you do if you don't know what the picture is supposed to look like? Well, start. Just start drawing. Start giving some doodles. Now, this last one. This is from the tail end of precalc, right? This idea of a difference quotient. All right. So what I do is I take my f. Remember, all problems on this page refer to this particular function. All right. So what I do here is, okay, if f of x is 1 over x minus 2 for x, right? Everything here is less than 2. If f of x is 1 over x minus 2, that means f of x plus h is 1 over x plus h minus 2. Minus 1 over x minus 2, this is f of x. And that's that piece there. Okay. 1 to 5, how do we feel simply about making the substitution? That's all I'm asking about. How do we feel 1 to 5 about making that substitution? Okay. Now what I'm going to do from there, I'm going to take a common denominator, right? So I'm going to multiply this by x plus 2, both top and bottom. I'm going to multiply this one by x plus h minus 2, top and bottom. And then when I take the common denominator, I'm going to move the bottom part here to this right here. And then I'm going to cancel these added, right? I've got an x and I've got a negative x, a negative 2 and a positive 2. That's going to leave me with a negative h, which will cancel right there. And then there's my final answer. Okay, so 1 to 5, how do we feel about this idea of doing the common denominator? All right. If this bugs you, if having this h on the bottom bugs you, do this. If that fraction of fraction bothers you, do this. So let's see. 1 over x plus h minus 2 minus 1 over x minus 2 all over h. What I'm going to do here is I'm going to simplify my life by writing this like the following. 1 over x plus h minus 2 minus 1 over x minus 2 times 1 over h. Okay, so some people just really don't like these fractions of fractions. And if that's the case, you could multiply it out. Right, I'm dividing by h, that means I'm multiplying by the reciprocal. All right. And then there's one I forgot to do, and that's this one. Let f be a real number so that t is less than 2. Evaluate this. This is f of t equals 1 over t minus 2. So how do we feel about that one, 1 to 5? All right, someone's raised their hand and then lowered it again. Do you have a question? Okay. All right. Are there any more questions about this stuff? All right. So what I'm going to do is I'm going to stop Twitch, and we're going to go back to just Blackboard Collaborate Ultra, and then I'm going to talk about how we're going to arrange the group work. So let's stop Twitch.